G'day folks. Today I want to go over the question number 7 on assignment number 5, and it has to do with the incremental rate of return analysis uh, for a company that has presented with 3 different options in order to replace a piece of equipment. So let's just quickly go over this this problem, and see how we go about calculating doing the incremental rate of return analysis for this course. So CB Electronics has 3 options. First option is that the supplier has given them, they can buy the equipment for straight out for $850,000. Second option is to pay the equipment off in 10 equal installments of $135,000 each, starting 1 year from now. So that means there's no money down at year 0. And the third is to pay $200,000 down now and an annual payment of $95,000 at the end of each year for the next 10 years. All 3 options are 10 years in length, so we can go ahead and look at the present worth analysis for these 3 options. So on the right hand side of the screen here, as I always do, I drew 3 cash flow diagrams for this particular problem. Okay, we have the first option where we pay 0 down, $135,000 per year for 10 years, and you see the associated present worth formula for that. Present worth equals 0 plus 135,000. Find P given A for I and 10, and obviously the interest rate is what we need to determine here for these options. Okay, option number 2, the first cost is $200,000. Again, 10 years to pay an annuity of $95,000, and so you can see the present worth formula that we calculate from this particular cash flow diagram. And option number 3 is basically paying the full lump sum down now, $850,000, and no more payments for the rest of 10 years. So there's A equals 0. Now, the critical thing that we need to do for anytime we're doing an incremental rate of return analysis is that we arrange the projects in terms of their lowest first cost. So you can see the table here in the solutions that the first cost, P1 is the lowest first cost, 0, obviously. P2 is the next highest in first cost, and P3 is the highest in terms of initial cost, first cost. Okay, you have to do that with every problem that I give you in terms of doing an IRR analysis. Arrange the projects in terms of lowest to highest initial first cost. Okay, so the first thing we need to do is we need to challenge each project against each other to find the incremental rate of return for each alternative. All right, so what we have first is project number 2 is going to challenge project number 1. And basically, all you do is you take the 2 formulas that you derived for the present worth of each of these options, and subtract project number 1 from project number 2. So we have here 200,000 minus 0 from the formulas here, plus 95,000 minus 135,000, all outside of P given A for interest rate of 10 years. Okay, so when you do some factoring out within the formula, it turns out that the P given A for I10 for this particular challenge is 5. And then this is where you use your tables within the text. From your tables, you look up P given A for 15% for 10, turns out to be 5.0187. P given A for 20% for 10 is 4.1924. We're looking for a value of P given A value of 5 for a particular interest rate. So this tells us that our interest rate for this particular challenge is going to be somewhere between 15 and 20%. Okay, so the MAR for this problem was 11%. We don't need to go any further and determine what the exact interest rate is, because all we need to determine is that P2 challenging P1 will give us an interest rate somewhere between 15 and 20%. That's a rate that's higher than our MAR. Our MAR was 11%. So that means that the challenge is successful. So P2 becomes the winner in this case. P2 becomes the current best, and now we're going to challenge P3 against P2. So we do the same procedure again. We take our formula for P3, present worth, subtract the present worth formula for P2. So we have 850,000 minus 200,000 plus 0 minus 95,000, P given A, I10. This time when we figure out P given A, I10, it turns out to be 6.842. And again, we don't go to our tables to look up see what interest rate we're dealing with. When we go to the tables, we see that the P given A for 7% 10 turns out to be 7.0235, and 8% turns out to be 6.7100. So we're looking for 6.842. This means that our interest rate for this particular challenge will fall somewhere between 7 and 8%. Now, somewhere between 7 and 8% is less than our MAR for this particular problem, less than 11%. So the challenge of P3 to P2 fails, which means that P2 becomes the overall best project. Okay, so the main thing to remember here is when you're doing any of these IRR analysis is to first arrange your projects in terms of lowest first cost to highest first cost, and then you challenge each project against the previous one. So P2 against P1, the winner of that gets challenged then by P3, and if there was another project here, we challenge that to the winner of P3, P2, and so on. And you work your way through the list using this same procedure. Once you determine where the interest rate falls, you can compare that to your MAR and determine whether the challenge succeeds or fails. Now, part B of the problem talks about where you actually go and solve the actual IRR for each challenge. Now, if we just look at the last challenge of P3 to P2, we know that we had a value of 6.842, and we have PA of 7 for 7.0235 and PA of 8 for 10, 6.7100. We use these 3 points in our interpolation formula, and we can determine that the exact incremental rate of return for the challenge of P3 to P2 is 7.5789%. Okay, this is obviously lower than our 11% MAR, and which means that the challenge of P3 fails and P2 becomes the overall winner. There's a mistake here on the notes. P3 is not the winner. P2 is actually the winner.